tangent to a circle property. Now, we've dealt with some tangents a little bit, but in geometry, a tangent line is defined as a straight line that touches any curve. So it just touches. What that means is this line right here is just touching at this point right here, or it's tangent. It's not intersecting, not going through the circles. And that's what we have here. It says when we're dealing with a circle and a tangent line, the line does not intersect with the circle, but just touches it. So it wouldn't cross or intersect. If we had a line that crossed, it would look something like that. And there clearly we have a line crossing a circle. But that's not what we have when we have a tangent. We have just a line touching at one point. Now, if that's true, here is the property of the tangent to a circle property. Is if a line is tangent to a circle, then the tangent line and the radius of the circle are perpendicular. Of course, perpendicular is 90 degrees. So this property right here, if we have a line that's tangent, then it's 90 degrees. The flip side could be true, is if we know that this is 90 degrees, then we know that the line is tangent. And it's always tangent to the radius. So the radius comes from the center of the circle, and we have that. That is the property of a tangent line to a circle. So let's use that idea in a couple examples here. So we want to determine the unknown lengths. Now, in these diagrams, in the diagrams you're going to see, if you have something that looks like this, now it looks like it touches a circle in a couple places, but it clearly isn't intersecting. Same thing with here. It's not intersecting. That's what a picture of a tangent line is. So if you have a question like this, then we can assume that that's tangent. And we're going to need that information to solve for x. So let's look at our first example. We want to find the unknown length. Well, if it's tangent, we know one thing that is going to help us a lot here. We know that this is at a right angle. Now, if that's a right angle, we have a right angle triangle, and we can use good old Pythagoras to determine what the entire length is here. And this entire length is the hypotenuse. We only want this little length right here, but there's something else that we know. We know that this length in here, from the center to the edge of the circle here, is always the radius, so we know that this is 5. So if this represents a length of 5, if we find the entire hypotenuse and subtract 5, we can easily find x. So let's go through and solve it. So we have 5 squared plus 12 squared is equal to, and I'm just going to call it h squared. So 25 plus 144 is equal to h squared. So h squared is going to equal 169. So h has to equal square root of 169, which is 13. And like we did before, x is just then 13 minus 5, which is just 8. So that length, unknown length, is just length 8. Let's look at the second example. Not quite as simple to look at here, but we got to do some things. And this is what you're going to find when you're doing these geometry questions. Sometimes you have to muck up your pictures. You got to draw on them. You got to do a whole bunch of things to try and figure some stuff out. So we have a triangle here, and we have a tangent. Now, this tangent line right here is not tangent to this line. It's tangent to a line that starts from the radius, or it's tangent to the radius, so a line that starts from the center. So that's the only thing that we really have here. It's clearly not an isosceles triangle, so we can't just make that assumption. But what we're going to do is, since we know that it's tangent, let's just draw in this line to the center of the circle. We know that that's the radius, and hopefully now what we can do is we can figure something out. Well, if that's tangent, we know that this angle in here has to be a right angle. So we know we have a right angle triangle right in here. Now if that's a right angle, and over here we have 50 degrees, that means this angle in here, though it doesn't look like it in the picture, and that's the other thing we have to be clear about here, is we cannot just make assumptions from the pictures. We have to go by what the geometry tells us. So this angle in here must measure 40 degrees. That is 40 degrees. Now, if that's 40 degrees, how does that help us? Well, here's what we have to recognize. And this is something that hopefully everyone has seen, because we're going to look at not only just properties to deal with tangents, but all the properties that we've dealt with in circles. So if this right here is 40 degrees, this is a central angle, this angle Z is an inscribed angle. It inscribes that same arc. So if I do the central angle here in black, and I do the inscribed angle, let's say we do the inscribed angle here in red, we'll recognize that it's actually the exact same, it subtends the exact same arc. Now, if that's true, we know that angle Z